Good afternoon, class. We are looking at chapter 6, periodic slash trigonometric functions, 6.1 graphs of the sine and cosine functions. So, chapter 6, periodic slash trigonometric functions, 6.1 graphs of the sine and cosine functions, 6.2 graphs of the other trig functions, tangent, cotangent, cosecant, and secant functions. And again, both of them more graphs, phase shift, PS for short, sinusoidal curve fitting. And then we go to the inverse sine, cosine, and tangent function. And finally, the inverse trigonometric functions. Continue with more functions. The objective of the section. Graphing sine function y equals a sine omega x by transformation. Graphing sine function cosine function y equals a cosine omega x by transformation. Determine the amplitude and period of the sinusoidal functions. Graph sinusoidal functions using key points, finding an equation for a sinusoidal function. Recall. Trig functions, the unit circle is a unit circle. Circle in general, if the center is at 0, 0, has the formula x squared plus y squared equals r squared. If the radius is 1, centered at 0, 0 is x squared plus y squared equals 1. So with that being the case, a point on a unit circle with coordinates x comma y, x is the same as cosine, y is the same as sine. And then tangent is y over x or sine over cosine, cotangent is x over y or cosine over sine, cosecant is 1 over y or 1 over sine, secant is 1 over x or 1 over cosine. That would be in the case of a unit circle. If it's a general case where x squared plus y squared equals r squared, that means the radius is not necessarily 1 anymore. X squared plus y squared equals r squared. P has coordinates x comma y or a comma b. Sine is y over r, and I'm going to stop right here because r is 1 in this case, in the case of a unit circle, and that's why sine is y here. Y over r or b over r, cosine is x over r or a over r, and the rest of them follow in the same manner. As long as we know the concept right here, we should be able to finish the rest. Then let's look at the trigonometric functions and their fundamental identities. X squared plus y squared equals 1, P has coordinates cosine theta and sine theta. A periodic function is the one that repeats its values at regular intervals. Sine of theta plus 2 pi equals sine theta. Cosine of theta plus 2 pi is cosine theta. Secant is the same thing. All trigonometric functions have 2 pi as a period. However, tangent and cotangent, the period is pi. Therefore, tan of theta plus pi is tan theta, and cotangent of theta plus pi is cotangent theta. Even and odd properties, even by definition, f of minus x is equal to f of x. Odd function f of minus x is minus f of x. Therefore, all trigonometric functions are odd functions like sine of minus x is minus sine x, except cosine. Cosine minus x is cosine x, and therefore secant, which is 1 over cosine, has the same property. Secant of minus x is secant x. Fundamental identities. Pythagorean identity, sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. Quotient identities. Tan theta is sine over cosine. Cotangent is cosine over tangent. Reciprocal identities. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. even and odd properties according to this. Therefore, we can say sine of minus theta is minus sine theta. All of them are odd functions except cosine and secant. Cosine of minus theta is cosine theta. Secant of minus theta is secant theta. So in short, all of them follow odd function with the exception of cosine and therefore secant. Section 6.1. Now new stuff. Graph of the sine and cosine functions. The graph of sine function y equals sine x we want to discuss first. Basically, plot points. If you recall, when we started graphing at the very beginning, even in algebra, we just plot points to get us started. So x sine x, x comma y, we start with, you can pick any point, and if need be, you use a calculator, but we go with the common arc so we know the answer. For example, 0, we know the sine is 0. Pi over 6 or 30 degrees is 1/2. Pi over 4 or 45 degrees square root of 2 over 2. Pi over 3 or 60 degrees square root of 3 over 2. Pi over 2 is 1. That's the first quadrant. Then we go with the easy ones. 5 pi over 6 is the same as pi over 6, which is 1/2. Pi is 0. 7 pi over 6 is in the third quadrant, the same as pi over 6, which is 1/2, but negative 1/2. 3 pi over 2 is -1. 11 pi over 6 also the same as pi over 6 in the fourth quadrant is negative 1/2. So 2 pi is 0. And now put them as a pair. So if you plot those pairs carefully, the graph looks like this. So we have one complete cycle. This is 0, 0. This is pi 0. This is 2 pi 0. This is pi over 2, 1. This is 3 pi over 2, -1. Maximum, minimum, x-intercepts. And there are other points as well. So y equals sine x. We are using 0 to 2 pi. One complete cycle, although the domain is all real numbers. So you can think of it as 4 pieces from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. This is using key points by using 4 pieces or 4 arcs. So graph sinusoidal functions using key points for arcs. So this is one arc. This is one of them. This is another one. This is the third one. So, and this is the last. So this is the first one, second one, third one, and fourth sub-interval. So what are the key points? Intersects. So 0, 0, pi 0, 2 pi 0. Maximum pi over 2 comma 1. Minimum 3 pi over 2, -1. So this is the fastest way to graph it. Just come up with 4 arcs. So a complete cycle, come up with the period, cut it into 4 equal parts. So the function y equals sine x. The sine function is a fundamental trigonometric function with several important properties. Let's quickly go over it. Periodic. The sine function is periodic with a period of 2 pi. This means that sine of x plus 2 pi is sine x for all x. Amplitude, domain, and range. The amplitude of the sine function is 1. This means that the maximum value of sine x is 1 and the minimum value is -1. Hence, The range of the sine function is between -1 and 1. The endpoints are included. Its domain is all real numbers. Symmetry, odd function. The sine function is an odd function. This means sine of minus x is minus sine x. Its graph is symmetric with respect to the origin. Key points, x-intercepts. The sine function crosses the x-axis at integer multiples of pi, x equals n pi, where n is any integer. Integers, okay. 0, 1, 2, 3 to infinity, -1, -2 to infinity. So the function reaches its maximum value of 1 at pi over 2 plus 2 n pi, and its minimum value of -1 at x equals 3 pi over 2 and 2 plus 2 n pi. This is pi over 2, and it repeats. If you add 2 pi, 2 pi, 2 pi, the same thing. 3 pi over 2 is -1, and it repeats if you add 2 pi, multiples of 2 pi. Remember, n is an integer. The y-intercept is 0, okay. Waveform, the graph of the sine function is a smooth continuous wave that oscillates between its max and minimum values, creating a sinusoidal waveform. Reflection to the unit circle. The sine function can be defined as the y-coordinate of the point on the unit circle x squared plus y squared equals 1. These properties make the sine function essential in various fields such as physics, engineering, and signal processing. When y equals sine x, period t is 2 pi, amplitude is 1. When y is a sine omega x, this one will change the amplitude to an absolute value of a. And because this is omega, it changes the period from 2 pi to 2 pi divided by omega. Many are real numbers from negative to positive infinity, but remember we have a complete cycle and then we extend it to both sides indefinitely. What about cosine? We do the same thing. We pick up easy arcs or angles. Again, you can use anything and use a calculator, but those are easier if we go that route. So therefore, we are going to go with 0, as you know. When x is 0, cosine is 1. Pi over 3 is 1/2, pi over 2 is 0, 2 pi over 3. It's the same as pi over 3 in the second quadrant is negative, so negative 1/2. Pi is -1. 4 pi over 3 is the same as pi over 3 again, but it's negative in the third quadrant. 3 pi over 2 is 0. 5 pi over 3 is the same as pi over 3. In the fourth quadrant is positive, so makes it 1/2, and 2 pi makes it 1. So again, these arcs are chosen such that it becomes easy to see the answers, okay? I hope everybody is following why we are choosing those answers. And so, of course, those are the pairs, and plot them. So plot them, and you get this curve. And of course, you continue indefinitely on both sides. This is one complete cycle. Y equals cosine x. And we are going to go from 0 to 2 pi only. Again, we're going to cut it in 4 pieces as we did with sine, because this is one arc, second, third, and fourth. So graph sinusoidal functions using key points or 4 arcs from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, finally 3 pi over 2 to 2 pi. So first notice the 4 arcs. This is one arc. This is the second one, everybody. This is the third arc. And this is the fourth. So there are 4 pieces. And in this case, we have 2 x-intercepts, power to 0, 3 power to 0. We have the maximum at 0, 1, 2 pi 1, and the minimum at pi negative 1. So use those information and you can easily graph it. Again, bear in mind, this is only one complete cycle. It continues indefinitely on the left and the right side because the domain is all real numbers again. So y equals cosine x. Let's look at the properties. The cosine function y equals cosine x is a fundamental trigonometric function with several important properties. Periodic. The cosine function is periodic with a period of 2 pi. This means cosine of x plus 2 pi equals cosine x for all x. Amplitude, domain, and range. The amplitude of a cosine function is 1. This means that the maximum value of cosine is 1 and the minimum value is negative 1. Hence, the range for the cosine is from negative 1 to 1. Its domain is all real numbers. Symmetry and even function. The cosine function is an even function. This means that cosine of minus x is cosine x. Its graph is symmetric about the y-axis. Key points, x-intercepts. The cosine function crosses the x-axis at odd multiples of pi over 2. As an example, in the first cycle. So 2n plus 1 times pi over 2. 2n is an even number, plus 1 makes it an odd number, where n is an integer. The function reaches its maximum of 1 at x equals 2n pi. For example, this 2, you see that? And its minimum of negative 1 as 2n, at 2n pi plus pi, or 2n plus 1 times pi. The y-intercept is 1. This one, 0, comma 1. So the y-intercept is 1. Waveform. The graph of the cosine function is a smooth continuous wave that oscillates between its maximum and minimum values, creating a sinusoidal waveform. Relation to the unit circle. The cosine function can be defined as the x-coordinate of a point on the unit circle, x squared plus y squared equals 1. These properties make the cosine function essential in various fields such as physics, engineering, and signal processing. When y equals cosine x, period is 2 pi, t equals 2 pi, t represents the period, amplitude is 1. If we go with a cosine omega x, we change the period as we did with the sine becomes 2 pi over omega divided by the coefficient of x, and amplitude is the absolute value of a. As always, the domain for sine as well as cosine, all real numbers. Let's look at this example when you graph sine functions in general y equals a sine omega x by transformation. There are several ways of doing it. One of them is transformation. Y equals 3 sine x. So first, when y equals sine x, the period t is 2 pi, amplitude is 1. When we make it a sine omega x, the period is 2 pi over omega, and amplitude is absolute value of a. So that's important to understand. So you want to do this by transformation, you just look at sine x. Sine x, you know how the graph is. Again, this is one complete cycle, and then you continue indefinitely on both sides. And we notice that we have to multiply this by 3. So what does it mean? Multiply by 3, vertical stretch by a factor of 3 gets larger along the y-axis by a factor of 3. So for the same x coordinate, the y is 3. So for example, this one doesn't change, but this one becomes pi over 2, comma 3. This one, 3 pi over 2, multiply by 3, you get negative 3, and the rest of them follow in the same manner. So this is y equals 3 sine x. As you can see, the domain hasn't changed. It's still all real numbers. The range was from -1 to 1, but now it's from -3 to 3. So the effect of that is changing the range of the resulting graph or function. We're going to continue. In this case, y equals negative sine 2x. We're going to do it by transformation, reminding everyone about x and y, sinusoidal functions, general basic one, y equals sine x or y equals a sine omega x, and information about the period, amplitude, and so forth. And of course, we start with the basic one, y equals sine x. So there are two things we want to do. There are two things that we want to deal with. One of them is this -1 in front. One of them is the 2 inside. You can do it in any order. Either way is fine. If you want to deal with the negative, so you're going to multiply it by negative, which means you reflect it about the x-axis. So this goes down, this goes up. If you look at just one cycle, it makes it easier to see. So this goes down, this goes up. And so, for example, pi over 2 minus 1 becomes pi over 2 negative 1, 3 pi over 2 negative 1 becomes 3 pi over 2 positive. Now, the next thing is to replace the x by 2x, which means horizontal compression by a factor of 1/2. So this thing is squeezed and getting smaller along the x-axis by a factor of 1/2. Meaning is pi over 2, you divide it by 2, you get pi over 4. Same y coordinate. This one, 3 pi over 2 divided by 2 becomes 3 pi over 4. 1 remains the same. And by the way, you can plug in, for example, pi over 4 into this, and it should give you -1. And I hope you see that it gives you pi over 2 sine is +1. This negative makes a -1. So you really should check it. So what about this information? T is 2 pi over omega. So 2 pi over 2. Domain, this one makes no difference. Negative to positive infinity. Range, -1 to 1, -1 to 1, -1 to 1. They are not changing. The only thing is changing is t, 2 pi over omega, 2 pi over 2. So the period, which was 2 pi, has shrunk to pi. Y equals 2 cosine 3x by transformation. Again, reminding you of all of this information that was given previously. We know when it's cosine x, the period is 2 pi, amplitude is 1. When it's a cosine omega x, the period changes to 2 pi over omega, amplitude changes to the absolute value of a. We know that. So sine and cosine makes no difference as far as finding those information. And so having said that, let's start with the basic y equals cosine x. And again, let me just do this so everybody can see. We are interested in a complete cycle, and the rest we can figure it out. So this is one complete cycle. Okay, that's the main part that we're concerned with, and then we extend it indefinitely on both sides. So there are two things we need to do. We're going to deal with this number 2 and this number 3. So 2 means multiplied by 2, and that means vertical stretch by a factor of 2, which means, okay, same x coordinate, the y gets multiplied by 2. So this becomes pi negative 2. This remains as 2 pi. This becomes 2. This one, 0, 1. 0 remains, 1 becomes 2. And then you can see the rest of them as well. Again, we are concentrating on the first cycle. So this is 0, 2 now. This is pi negative 2. This is 2 pi 2. And as you can see, the period hasn't changed. Now, 3x. That means you want to replace the x by 3x. This is a horizontal compression by a factor of 1/3. In other words, just anything that you see, don't change the y, change the x. How? Divided by 3. Doesn't get multiplied by 3, it gets divided by 3. So the 0 doesn't change. So this is still 0, 2. But this one divided by 3 is pi over 3, same y. This one divided by 3, 2 pi over 3, same y coordinate 2. So it has an effect on the period. So the period is 2 pi, but this one gets divided by 3. So again, look at 0 to that doesn't change. Pi negative 2 is pi over 3 negative 2 because of this 3. And this one, 2 pi is 2 pi divided by 3, 2. Again, just look at one complete cycle. The period, which was 2 pi, now is 2 pi over omega. 2 pi over omega, 2 pi over 3. That has changed. Now, notice the domain, of course, can't change. All real numbers, all real numbers, all real numbers. Range, negative 1 to 1. Range has changed here. Therefore, the range for both of these functions are the same from negative 2 to 2. Domain is all real numbers. And the period, as I mentioned, 2 pi over omega or 2 pi over 3. So two changes, the period and the range. Sinusoidal functions, we should recognize that sine and cosine are basically the same in the following manner, that sine is cosine of x minus pi over 2. So notice the cosine x, notice the sine x, and if you move the cosine by pi over 2, move by pi over 2, let's start. See, pi over 2 is right here, right? Let's say this point. Just look at this point on the rate function, which is the cosine, just this point. Move it by pi over 2, becomes what? The blue one, which is a sine function. Okay. And if you go with the graphing calculator, put y1 equals sine x and y2 is cosine of x minus pi over 2, it just gives you one graph. So how many graphs do you see? And that's the idea. How many graphs do you see? So that's what happens, everyone. Example 4, y equals negative 4 cosine of 3x. Determine the amplitude and period of a sinusoidal function. And again, reminding everybody of what we have discussed, and we are interested in one complete cycle. So y equals negative 4, 3x. negative 4 cosine of 3x. So the amplitude is the absolute value of the coefficient of cosine. So the absolute value of negative 4, which makes it 4. T is 2 pi over omega, 2 pi over 3. The amplitude is the absolute value of 3, which is still 3. The period is 2 pi over omega, which is 2 pi over 4, which makes it pi over 2. So that's pretty straightforward, everybody. So a quick recap. How do we find the amplitude? The number sitting in front of cosine or sine, you take the absolute value. How do you find the period? 2 pi over omega. What is omega? The coefficient of x, the coefficient of x. In other words, look at the argument of cosine, 3x, so divide by 3. Look at the argument of sine, 4x, divide by 4. That's how we find it. So that's pretty straightforward. Now, steps for graphing a sinusoidal function of the form y equals a sine omega x or y equals a cosine omega x using key points. Step 1, determine the amplitude. A period t equals 2 pi over omega. Step 2, divide the interval of 0 to 2 pi over omega into 4 subintervals of the same length. Step 3, use the endpoints of these subintervals to obtain the 5 key points on the graph. Finally, step 4, plot the 5 key points to obtain the graph of one cycle, connect and extend on each side to make it complete. In other words, you get one cycle and then continue indefinitely on both sides, the left and right. That's the idea. Graph sinusoidal functions using key points where y is 4 cosine of 2x using key points. Again, reminding everybody of that. Amplitude is absolute value of 4, which is simply 4. Period t is 2 pi over omega or 2 pi over 2, which is pi. Now the next step is to cut the period into 4 equal parts, so simply divided by 4. Now we want 4 subintervals. Starting from the beginning, it happened to be 0, by the way, because one complete cycle goes from 0 to pi. So from 0, and this is pi over 4. 0 to pi over 4, pi over 4 to pi over 2, pi over 2 to 3 pi over 4, 3 pi over 4 to pi. Those would be the 4 subintervals. Now let's plug in. If you plug in 0, cosine of 0, 1. So you get 4. Pi over 4 times 2 is pi over 2. Cosine is 0. Pi over 2 times 2 is pi. Cosine of pi is negative 1. Times 4, negative 4. I figure out you can do the rest. So one more time. If you plug in 0 here, you get cosine of 0, which is 1. 4 times 1 is 4. Okay. If you put pi over 4, you get pi over 2. Cosine is 0. 4 times that is 0. If you plug in pi over 2 times 2 is pi. Cosine of pi is negative 1 times 4 is negative 4. You can clearly figure out the rest. So plot 1, 2, 3, 4, 5 points in a rectangular grid. So this is number 404. Pi over 40, pi over 4 negative 4, 3 pi over 40, pi comma 4, and now connected. That's the answer. This is one cycle. But to graph this, you have to go indefinitely on this side and on the right. So it's very straightforward. So that's, I believe, pretty straightforward, everybody. We are going to move on. We're going to continue and look at this function, graph y equals negative 3 cosine of power 4x using key points. Amplitude is absolute value of negative 3 or 3. T is 2 pi over omega, 2 pi over 4. 2 pi over 4, making it 8. So the period, instead of 0 to 2 pi, is 0 to 8. You cut that into 4 equal parts. 8 divided by 4 gives you 2. Therefore, 0 to 2, 2 to 4, 4 to 6, 6 to 8, those are the 4 subintervals. 4 subintervals. So you start plugging the endpoints. You plug in 0. Cosine of 0 is 1 times negative 3 is negative 3. The other endpoints is 2. If I plug in 2, I get 2 pi over 4. 2 pi over 4 is pi over 2. Cosine is 0 times any number is 0. So that means 0 corresponds to negative 3. 2 corresponds to 0. What about 4? If I put 4, the other endpoints, 4 divided by 4 is 1. Okay. So we get 1 pi, and cosine of pi is negative 1. This makes it positive 3. So 4 comma 3. 4 comma 3. If you plug in 6, 6 over 4, 3 halves, and 3 power 2 cosine is 0, and so forth. So you should have no problem figuring it out. Again, plug in 0 gives you negative 3. Plug in 2 gives you 0, and so forth. So plot the pairs. You have 1, 2, 3, 4, 5 pairs. You plot them. 0, negative 3, 2, 0, 4, 3, 4, 3, 6, 0, 8, negative 3. That's the graph. And this is one complete cycle. That means if they ask you for complete cycles, one complete cycle, you're done. But you're going to go indefinitely on the right and left, and that's what you get. So it's pretty straightforward, everybody. We are going to move on. I just want to make sure that everybody is fine with what we just looked at. Now we're going to continue, but this time we are looking at y equals 5 sine 3x using key points. So let's see what we need to do. First and foremost, 5, the amplitude is the absolute value of that, which makes it 5. The period is 2 pi over omega, 2 pi over 3. We are going to divide this by 4 equal parts. So divide this number by 4, you get 2 pi over 3 divided by 4. That means pi over 6. Now, we get 0 to power 6, power 6, and then add power 6, you get power 3. Power 3, add power 6, you get power 2. Power 2, add power 2. Power 6, you get 2 power 3. Those are the 4 sub-intervals. What are the key points? Let's plug in. I plug in 0, I get sine of 0, which is 0 times 5 is 0. I plug in pi over 6. So just again, I want to make sure we understand that. We just plug in this one. We get 5 sine of 3 times pi over 6. 3 pi over 6. Pi over 2. Sine is 1 times 5 is 5. Let's plug in pi over 3. I get 5 sine of 3 times pi over 3. That means pi sine of pi is 0. I get 0. So I hope you can see how we can arrive at the answer. Let's put pi over 2. Let me use a different color. Pi over 2. So 5 sine of 3 times pi over 2. And this is -1. So you get -5. So these are the pairs, and I didn't do the last one. I hope nobody has any problem finding them. Okay, let me erase my work. Now plot 0, 0, power 6, 5, and the rest of them. So here's 0, 0. And by the way, this is 2 power 2. You cut it into 4 pieces, okay? So this is power 6, 5, power 3, right in the middle of these two. 0, power 2, -5, 2 power 3, 0. That's the sinusoidal waveform. And continue indefinitely on the left and right. And that's the graph, everybody. So that's pretty straightforward, everyone. All right, let's look at this one and see what we get. We have y equals 2 sine minus power 2 over minus power 2 times x. First and foremost, when the argument is negative, you want to get rid of it, make it positive. How? Depends whether the function is odd or even, and I hope you recognize and remember sine is an odd function. Therefore, if you take the negative out, sine becomes negative, so you put a negative in front. Again, all trigonometric functions are odd functions except cosine, and therefore secant. Okay. So I hope everybody understands what I'm saying. Okay, so because it, cosine is an even function, so is secant as a result of that, because it's the reciprocal of that. All right, so having said that, let's take care
I
of the
need a
business
critique
here.
from both. You need to critique two people, right? Anyway, for the class.
Excuse me?
Oh, okay. I was like, yay or nay? You guys are
Okay. All right, we have resumed the recording. Let's continue on that thoughts. The amplitude is the absolute value of -2, which is 2. The period, 2 pi divided by pi over 2, 2 pi over omega. Omega is pi over 2 here. We are looking at this one. And 2 pi divided by pi over 2 gives you 4. 4 will be cut into 4 equal parts, becomes 1. So we start from 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4. Those are the 4 sub-intervals. What are the key points? Well, plug in 0. Sine of 0 is 0. 2 times that is 0. Plug in 1. Okay. You can plug it into the original one, or this one makes no difference. Maybe it's easier to put it here. Pi over 2 sine is 1. -2 makes it -2. If I plug in 2, sine of pi is 0, so is -2 times that. If I put 3, 3 pi over 2 sine is negative times -2 becomes +2. So we have those 5 key points. We have the 5 key points, everybody. Plot the 5 points. 0, 0. This is 4. Cut it into 4 equal parts. 1, -2, 2, 0, 3, 2, 4, 0, and now here's the graph. Connect. And then on the left and right, continue indefinitely, and that is the final answer, everybody. You're going to move on. So what about this one? Y equals -4 cosine pi x minus 2 using key points. You can ignore this for now. This, as you know, means transformation along the y-axis going up or down. In this case, -2. If you graph this one, it shifts down by 2 units. But for now, let's just concentrate on this. The amplitude is the absolute value of -4, which makes it 4. The period is 2 pi over omega. Omega is pi, 2 pi over pi, or simply 2. Because we want 4 subintervals, we're going to cut this in 4. 2 divided by 4 is 1/2, which means we're going to go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. And those endpoints, we're going to plug in into this one. If you plug in 0, cosine of pi we get -1, and we get -4. 1/2 cosine of pi over 2 is 0. 1 cosine of pi is -1 times -4 is +4, and so on. So those are the 5 points. Just as an example, you can plug in 2. Okay, 2 pi is cosine of 2 pi is 0. Cosine of 2 pi is the same as cosine of 0, which is 1. times -4 makes it -4. So let's plot those 5 pairs. 0, -4, 1/2 0, 1 4, 3/2 0, 2 -4, and we connect them. That would be the graph. Now we're going to add to both sides indefinitely, left and right. This is the graph of this function, not what they ask. This is the graph of y equals -4 cosine of pi x, not what they ask. So how do we find this one? Just use the same graph, shift it down by 2 units. Shift down by 2 units. Subtract 2, vertical shift down by 2 units. So the result is, for example, -1 4 becomes -1 4 minus 2, which is 2. 0 minus 4 becomes 0 minus 6. 1 4 becomes 1 2, and so on. So you shift it down by 2 units. All right, example 10, we want to find an equation for a sinusoidal graph, and it may not be unique. Find an equation for this graph. You pay attention to a complete cycle and never mind the rest. That makes it easy to figure out what you have. First and foremost, if you look at this, you notice that it's a cosine function. Looks like a cosine, not a sine. Okay, that's important to recognize. Then you put the important points there. For example, this one has coordinate 0, 3. This one seems to have a coordinates 1/2, -3. This one, 1, 3. So the fact that it looks like it's clearly a cosine function. So y equals a cosine omega x. We need to figure out the a, we need to figure out the omega. Because this is, instead of 0, 1, it's 0, 3, and this is 1/2, instead of -1 is -3, clearly the amplitude is the absolute value of 3, or a equals 3. Then we remember that t is 2 pi over omega. This is a period of 1. That means t, which is 2 pi over omega, must be equal to 1. This is the period. T, which is 2 pi over omega, is equal to 1. So what is omega? The product of these two, omega times 1, 2 pi times 1, omega is 2 pi. And so now that we have both of them, we replace the a, we replace the omega, we get y equals a cosine omega x equals 3 cosine 2 pi x. And it's always important to check. All you have to do, plug in 0. Cosine of 0 is 1 times 3 is 3. Plug in 1/2. 2 pi times 1/2 is pi. Cosine of pi, -1 times 3 is -3. Plug in y, 2 pi. Cosine of 2 pi is the same as cosine of 0. It's equal to 1 times 3 is 3. So, and of course, you can look at the intercepts also. Those are easier points in this case. Finding an equation for a sinusoidal graph, and before even we move on, you may recognize this as a sine graph that has been inverted, but in any event, let's put important points. We can read 0, 0, 2, 0, 4, 0. This is 1, -2, and this is 3, +2. So definitely a sine function, y equals a sine omega x. The amplitude, if you look at the fact that the maximum occurs at 2, the minimum occurs at y equals 2 and -2, that means the amplitude is the absolute value of -2 or 2. And what is a? Is it 2 or -2? Note that this is a reflection over the x-axis of the sine function, because remember, the sine function looks like that, but this is inverted. So clearly, a is -2. So we have that one. The last thing is to find omega. Remember, t is 2 pi over omega. So t is 2 pi over omega. But what is t equal to in this case? In this case is 4. So t, which is 2 pi over omega, equals 4. Cross product 4 omega is 1 times 2 pi. So omega is 2 pi over 4, which makes it pi over 2. And now we can write y equals a sine omega x. Replace the a with -2. Replace the omega with pi over 2 and check. So, for example, if you plug in 0, that becomes sine of 0, which is 0 times -2 is 0. If you plug in 1, sine of pi over 2 is +1 times -2 becomes -2. You can check the rest of them as well. And I want to finish this off with reminding you, therefore, of this summary. Graph sinusoidal functions using key points or arcs. That's the fastest way. A basic one, which goes from 0 to 2 pi, gives you those 4 subintervals. From 0 to 2 pi, cut it into 4 pieces. 2 pi divided by 4 gives you pi over 2. So 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and finally 3 pi over 2 to 2 pi gives you the following. And plot the endpoints. Same thing for the cosine. Plot the endpoints, and you have the graph. This is the fastest and easiest way to graph this sinusoidal functions.